Okay, we are live. Hello everyone, my name is Tarun. I am a DevRel and Community Manager at AI Planet. Today we have Gus Martins, AI Developer Advocate at Google, who has shared multiple sessions regarding AI, LLMs, and also generative AI. Today, Gus will be sharing his expertise on introduction to LLMs with PaLM API and MakerSuite. So, without further ado, let's welcome Gus. And if you can start with about yourself, and then we can move on with the session.
Of
And
course,
thank you for accepting our invitation.
of course. Hi, thanks for the invite, Tarun. I'm very glad to be here talking to you. I hope I can teach something and that's helpful. As you said, I'm Gus. I work as machine learning developer advocate at Google. My goal is to help developers use machine learning the best way possible, solve their problems in a way that's good for them, that's responsible, that they get better solutions for their products in a way that everyone wins. So that's basically what I do. I've been doing machine learning for some years already, so it's kind of my what I really like to do. So thank you very much for the invite. Uh, so today I'm going to talk about large language models. I'm going to go a little bit over what it is, and then I'm going to talk, of course, about the PaLM API, and I'm going to talk about MakerSuite, and then you understand how everything connects, why use specific tools. This is a very introductory talk. I hope it's very basic. You can follow it. There's no super advanced topic here today. So without further ado, let's go. So let me just choose the proper screen. Sorry. So today I'm going to explain a little bit what's large language models, why they matter. I'm going to show you how you can prototype an application right in the browser without installing anything. And then we are going to see also how to do the same thing using code, which is the follow up when you need more flexibility. And we're going to explain all of that. But before we get there, we need to understand what's LLM, right? So people use this term non-stop now. It's very popular, let's say like that, since end of last year. So LLM stands for large language model. But before we get to a large language model, we need to understand what's a language model. So in machine learning, one very hard task that people have been struggling to solve for a long time is how to make the computer understand text, because text is it's hard. It's just hard. It's way harder than an image to understand, and this is because words can have different meanings, even exactly the same word, right? So if you have like a bank, uh, it can mean many things depending on where it is on a sentence. And if you change the way the sentence is with a comma, it can change the meaning of the sentence. So understanding text is not obvious, right? And language models were uh, it's kind of the solution, right? So in what we the language model learns to do, the basic task that it learns to do is you give some text and it can predict the next word of that text, right? That's all it can do. So if we say roses are red, the next would the model would complete is violets are blue, sugar sweet. And this is because it has was trained on poetry, for example, right? So it learns these patterns. The idea is that these language models, they learn the patterns of the language. That's it. It can complete the next word. It's like a super powerful autocomplete. And the autocompletes are based on language models, right? So they are statistical things. The cool thing about these, when you start to train with more data, when you start to go into the field of large language models, and these language models start to get way bigger, is that they can do more than complete regular text. So if, for example, you give to them this beginning here, for var I equals 0, if you are a developer, you kind of know what comes next, right? And the large language model can also do that for you. It knows what's next. And it's not because it understands all the meanings behind it, just because it's, oh, what's the most probable next couple of letters I can put here? And this is a very obvious one, right? Because that's what you see everywhere. And again, it's a super powerful autocomplete. And when we start to talk about the modern large language models, uh, is the main thing here is that they are very large. They are super big. They have been trained with billions of data, let's say like that, right? So they use all the internet, all everything you can see on the internet. You can see books, Wikipedia, everything. It's all they train on all this data. And as you can imagine, this is a lot of information, right? So this is why we say the large language models. These models are super big. They are compared to other machine learning models. It's like orders of magnitude larger. And uh, of course, they have a challenge by itself just to do anything with them because they're too big. But they also bring a lot of very special capabilities with them. So one thing that they can do, all of just by being trained, they can solve most of the classical natural language problems without need any other fine tuning. So, for example, classification. Let's talk sentiment analysis. Sentiment analysis, when you do natural language processing, usually what you do is you get the data, like the IMDb data set for positive and negative sentences, and then you train a model, and then you have your model that can do sentiment analysis, but it can only do sentiment analysis. Or you can train something to classify text or to do summarization. But you in the past you had to train specific models for each one of them. When we talk about large language models, they can do all of these by themselves without any fine tuning, without retraining, without anything. They just can do all of that. So you can ask a question, hey, is this sentence positive? And it will say yes, no, and give you some follow-ups on that. And they can do also translation. They're very good in summarizing content for you. And this is because they're trained on so many things that they can do so many these classical problems. They can do all of them, and they can go even further. They can, for example, they can explain a joke. Explaining a joke is hard, right? For humans it's cringe because when you explain a joke it's because your joke is bad. But for a machine to explain a joke is hard because it requires a context that is way larger than just the joke, right? You need to understand uh, plays with words sometimes or other references, and this is way harder. And these large language models can do that. They can do even more things. They can help you do ideation, right? Get ideas or explain things to you step by step, or you can ask for a rewrite of your text. They can do many more things. So these they're very, very powerful. And because they're super powerful, you can do a lot of things with them that wasn't possible before. And this helps you prototype up new applications much faster. Remember, I told you that on classical NLP, you would need to train a model to do sentiment analysis, right? For example. Here, you don't. And the training a model to do sentiment analysis, that takes a long time because if you are going to do that on real project, you need the data, and to get the data it might take a long time. And then you need to build a model, and then you need to train the model, and then all of that, you skip all of that. You have the model already. It's have, oh, but my use case is a little bit different. Yeah, that will work. That's the thing. You don't need to customize for every use case, and that's very powerful. So this prototyping uh, is absurdly powerful, and we're going to put some time here. Let's understand that better. And how would you do prototyping with these large language models? First, Google provides the PaLM API, which is an API to access the PaLM model, PaLM 2 now, that's behind this API, and it enables you to access and work with this model for your application. Uh, this API is free for you to access. I don't think there's any cost as of today, and you'll see many libraries to how to do that in code. But the thing is, if you want to just start playing with it, you are not going to start by writing code. You can start by playing with the large language model right on your browser using something that we call a tool that we call MakerSuite. And we're going to see many examples using it so you can understand what it can do and how it can help you. I'll give you all the links at the end, don't worry. It's just one link, but you get all of that. So MakerSuite will help you create applications or play with these language models super fast right on the browser without installing anything, without downloading anything. You just log in and you can go on and play with that. That's very good. Before we go into that, we need to understand how we use these models. So the fun thing about these models is that they have a different way of dealing with them, right? So it's a different way of communicating with them. You can talk to them in regular language, regular human language. For example, English. So you just ask what you want. And this way of talking to large language models is what we call prompt engineering, because what you do, you create a prompt. We are going to see many examples, so it will be very clear what a prompt is. So when you see people talking about prompt engineering, prompt design, prompting, this is the way to communicate with these large language models, right? It's a new way of communicating to a machine learning model. And let's take a look on this example here. So we are going to use MakerSuite here and do a simple prompt. And this is the UI, right? You go into the text prompt, which is the basic one. And I'm going to ask for it to give me ideas to do a theme party for my daughter's birthday. And so I give the model some context there. Let me just scroll here. Yes, so let's just take a look on this one. So my prompt is, help me plan a theme party for my daughter's birthday. She's 11 and loves to read. So I'm giving a context and I'm asking something, right? The context is, it's my daughter's birthday. She is 11 and she loves to read. So the machine learning model here, the large language model, the PaLM model, will get this and will plan a party. I'm asking something, it will give to me. So I give the prompt, it will give me a response. If you look into that, it's very good because it shows tells me how the invite should be, the theme, the kind of food, activities, the goodie bags that we give to the kids after the party. And that helps a lot. It's all connected to books. This is very powerful, right? And I did that. I got all these ideas that I can, of course, work on it. I might ask for to elaborate. I can get specific parts and work on that. All of that with only one prompt, right? This wasn't possible in the past. Definitely not possible before large language models. So this is for text prompt. But in some situations, we need to do better. Let me go to the... Sorry, it's my bad here. Yes. Let's go to the next, and let's do... in some situations, just the text prompt is not enough. Then we have to do different. We need to do a data prompt. And this is what we're showing here. A data prompt... I'm going to pause while I speak so you pay attention. A data prompt is, I give you a context, and I also give you examples of what I want and how I want the model to answer. So here, if we look here, I'm asking the model to generate some thoughtful and creative questions from the text provided. Structure your questions or creative speculations for where the story could go. So the idea is, I have some paragraphs. I want the model to generate questions that will help me continue the story based on these questions. That's it. And so I'm asking something. I'm saying, hey, do this for me. And it's on this format. I'll give you a paragraph and you give me questions about this paragraph. That's it. So this is very hard to explain as a regular, just like explaining word by word. So I give examples. And this is what's happening here. This is the MakerSuite doing the data prompting, we call this. We give a context. we start the prompt, right? And then we give an input, output, input, output. And then here at the bottom, I'm going to add a paragraph, and it will run for me, and the answer will be here on the output as I requested. As you can see there, uh, it generated questions for me to continue my paragraph, just based on my examples. So this is another way of doing prompting. You not only give ask something, you give examples of what you want, and this is very powerful, right? This, you can see that even the numbering of the list, it copied from the sample, from the example I gave. So this is very, very powerful. And let's see something else from MakerSuite, which is this that I just showed. I can generate the code for that. So if you want to go to Python, for example, here is the code you would need to do exactly the same thing using our Python library that will call the PaLM API the same way that MakerSuite did. You can do, there's a JavaScript, we have a library for Swift and other languages. I'm going to show that later. And you can export to Colab and go on from there. So you start playing on MakerSuite, and then you go and follow to the next how do we say, go follow up on code, right? Let me continue. So this was data prompt. The problem is, not the problem, the challenge is not all applications for large language models can be solved like a text prompt or just a data prompt that we saw. You've seen, of course, that they can be used as a chat agent. You can talk to them. You can ask questions, get answer, response, and go on and so forth, like Bard do, for example. If you play with Bard, you know what's a chat with a large language model, right? And MakerSuite can help you also with that. But the next one. Yeah, so if you see Bard, let me give an example of Bard here, just in case someone didn't see that. So Bard is a chat interface where you can talk to a large language model. It uses also the PaLM 2 model in the backend. Of course, this application is richer than just using the API. It does way more things because this is an application built over the API, right? So it's, of course, more complex. As you can see here, asked for a tip how to do tourism in São Paulo, and give me a list with pictures, links, and stuff like that. So this is a chat interface. The difference for the chat interface, give me a sec, I hate playing videos, man. The difference of the chat interface with a model is that it's more complex. So first of all, it has a context because you have to tell the model how it should behave. We are going to see an example that will make that absurdly clear. And then we can give examples of conversations. We can send a example message 1, example response 1, and so on and so forth. And this creates something we call conversation history. So we have a context, which is you are a machine learning developer relations, and you like to talk about large language models. So you're setting up the model to behave as someone or something, right? And then you give some back and forth conversation, and this is the conversation history. So we have context and a conversation history. Why that's important? Because when we have a conversation, when I say something, I say, okay, who is the president of the United States? Then the model will answer Joe Biden. How old is him? When I say how old is him, who this him is to who? Who is him? Of course, as a human, you would understand that you are referring the previous question, right? For the model to understand that, they have to have the conversation history so that they can look and say, well, who was mentioned earlier? Oh, Biden. Okay, Biden is, I don't know how many years, right? 80 something. And the idea here is that this conversation history helps the model understand the context better and do better the next steps. So this is very, very important. Let's take a look how to do that on MakerSuite. We have here a chat prompt that we give you the interface here, and I want the model here to talk like a pirate, right? Just for the fun. And I'll give the context, and it's, hey, talk like a pirate. use that lingo. And then I'll give a user question and the model output. This is an example. I'm telling the model, hey, this is an example that you can follow. Remember the data prompt I just mentioned? Same idea here, right? You give examples. And now, just with that, I wrote like 3 lines there. I can ask the model, which is on the right side as I'm doing here. I'm going to ask a question, and the model will already use that as context and examples on how to talk. So you can see what do you like to do, and then it will answer like to sail, blah, 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 blah. Yes, sail the 7 seas and plunder. So the answer, I'll pause here. The answer is on the pirate lingo already, just by those 3 sentences. And again, the same thing. This can be exported to code, and you can go on and build your own conversation bot. And this is very, very important. We're going to see more details in code soon. Oh, sorry for that. Of course, doing chat conversations like a pirate maybe is not the best business case, right? But you can use chat conversations for many other things. For example, customer service, a personal assistant that knows about your data and talks only to you. And you can do storytelling, customer feedback, and conversation product recommender that you can talk to the store. For example, hey, I'm looking for something like this, and that, and the model will recommend stuff for you. So all of this can be powered by this kind of chat applications. And of course, the context is important. So you can understand how much context in the conversational history is important. Imagine if you want to talk to those telecoms and you start talking to someone and you give your data and they keep asking your data non-stop, every step. Can you confirm your name? Yes, Gustavo. Okay, what's your question? My question is, how much does the plan cost? And then they give you an answer. And then, okay, I want to buy this contract, to get this contract. Okay, can you confirm your name again? And then you can keep doing that for every request. Can you imagine how horrible that would be, right? So this is why having the conversational history and the context is so important. Now that we know how MakerSuite works, let's take a look on how to use that in code, right? So we are going to go over 3 examples, which is reverse dictionary, chat, of course, with an alien, and talking to the documents. So we are going to show how to build these kind of examples, and using the PaLM API, then you can do whatever you want with that, can go on. For here, for example, I'm showing how you would do the reverse dictionary on the MakerSuite. So what I do is I give you a prompt, and then I give you some examples, just very basic examples, and I end with missing part of I give you describe for me a type of vehicle that goes under the water, and I don't put the answer, because then the model will understand, oh, I need to follow up here. This is one way of doing that. And then you can export exactly that to Python and use that on Colab, or you can use on other libraries we have. Like we have library for Node.js, Swift, Java. I guess we have a Kotlin. There, every time there's a new library for the language to access the PaLM API, so that's good. And let's take a look how to solve that problem. For reverse dictionary, we're going to use the text endpoint. We're going to show in a little bit. For the chat with an alien, we're going to use the chat endpoint. And talking to the documents, we're going to use embeddings endpoint. So we have 3 endpoints that are what we need to learn to use the API. The text endpoint is the one that you just give a text and the model follows the prompt you give or completes the word you need. Before going to use that, we need, of course, to pip install our library, the Google Generative AI. We import, and then we get the API key. The API key you can get on MakerSuite. So, this is you just click on create new API key to give you a long string. Of course, API keys are like your password, so don't commit them to your public GitHub repository. You should keep them safe so people don't abuse your key, because if they abuse your key, it's abusing on your account. So if someone blocks your account because you abuse the API key, you lose your account because you committed your key somewhere and people are using it. So let's take a look at how to use the API. The first method, I guess the easiest one is list models. So you just get PaLM, that was the object we created here. Here, PaLM configure, right? We imported PaLM, configure, and now we can list models. It will list you all the available models. I guess we have Bison, which is a large one. It's not the largest one. I guess we have another one called Gecko, but I need to verify if it's on the API already available. But Bison is what we use the most recently. And then I'm creating a prompt. This is a string, right? A Python string prompt, as I showed on MakerSuite, is the same here, same thing. And then I just call palm.generate text, choose the model, give the prompt. That's it. The response will be on this completion variable. On dot result, you get submarine, which is what the model gave back, which is exactly what we want, right? A vehicle that goes under the water. So this is how to use the generate API. This is the text endpoint. We could add some parameters. For example, there's one called temperature. Temperature, it tells you how creative the model will be. So the higher this number, the more creative the model will be. In some situations, you want the model to be really wild and give you things you didn't think about. For other situations, you don't want that at all. You just want factual things. Even with very low temperature, the model can still create random stuff. This is part of large language models. We're going to discuss this in a little bit when I talk about responsible AI. But the temperature will help you anyway if you want something more random, less random. So this is an important parameter here. Let's take a look on chat. So the chat API is very, very simple. It's palm.chat, and then you define a message. That's it. If you look into the response.last, you have what the model replied. But this is just the beginning, right? We want to do the alien thing. How do we do the alien thing? First, we define a context, and the context is be an alien that lives on one of Jupiter's moon. So I'm telling the model, pretend to be this type of alien. That's it. And then I'm going to give examples of the conversation, right? How is it going? Oh, I'm doing well, blah, 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 and lots of text explaining how the alien is feeling, right? As you can see, I created a context variable and an examples variable. And this is very important because now I can give this to the palm.chat, a context and examples, and I'm going to give a new message now. This, I'd like to visit, what should I do, right? When I do that, the response.messages will have my message plus the answer from the model. We can call the response.last, which is only the answer from the model if you need. And I can do on the same response object, I can call the reply method. Reply method will get my question, add to the conversation history, and the model will reply again based on that, right? So you can go on and keep replying. Why does this is important? Why do I have context and examples? Because these models, they have a limited input window. What is a context window they call? This is the number of characters I can give to the model, and it will accept as input. So if you did anything about machine learning in your life, you know that the input size of your model is always something that's kind of defined, right? For these models, is like they have a context window, depending, might be 8,000 tokens, which would be close to 30,000 characters, but that depends on many things. And so that's a problem, because if your conversation becomes too long, how do you make that work, right? And think like this: every time you send a question answer, the PaLM API will keep this conversation history, so it will keep only growing. So what you send to the model, you send everything, and the model reads everything and say, oh, I have to answer this. It's not as if the API remembers you. It doesn't remember you, but it has the context. Every call, you give all the context. So you can imagine that at some point the context is too large. So what happens is you cannot lose the context. Otherwise, all of a sudden the model forgets they are an alien. And then you lose the magic here. And it can also forget the examples, right? And then it might start to answer randomly. So what it happens is the PaLM API will get the context and examples. They'll always keep that on the context window, and the message history, conversation history, it will go on until it's full. When it's full, it starts to delete the older messages. So it's a rolling thing. That's the way they solve the context window here. So it's not an endless thing. So after, if you ask, the first question is, hey, what's your name? Or you say something, remember I like apples, right? And then you fill the conversation history. And after you fill and the first message has gone already. If you ask what's my favorite fruit, it will not remember, right? So that's an interesting aspect here. Let's take a look on embeddings now. What is embeddings? Embeddings is a way of representing text as numbers. Remember, I said right at the beginning, it's very hard to represent text as numbers because some words may mean different things depending on where they are in the sentence. And embeddings is a way of fixing that. Embeddings, you change a word or a sentence for an array with thousands of numbers. These thousands of numbers represent the n-dimensional space, where n is the number of numbers in the array. So imagine you have like a 3-dimensional space, right? You get a sentence and you replace by 3 numbers. What these embeddings mean is that if you look into the space, 2 sentences, if their embeddings are close to each other in the 3-dimensional I'm giving, so you can visualize space, it means that these sentences are similar somehow. If they're too far, is that they're not related. And that's why we have 1,000-something dimensions. So you can represent a lot of stuff. It's a lot of information here. And this is what embeddings is. So embeddings can help you find answers on text, find answers on something, find similarities. That's what we're going to use to talk to documents. So what I want to do is I want to ask a question, and I want the PaLM API to show me the TensorFlow documentation where that answer is. So what I have to do is first of all, I retrieve the embeddings from the question and save it on a variable. I go over and I run embeddings, extract embeddings from all documents on TensorFlow site, for example, or on one site, doesn't matter, all the embeddings. And then I call, to get the embeddings, I'm using the PaLM API. We're going to see that. And here's how I call the embeddings. I generate embeddings, I give a text, it will return an array. Simple as that. Same thing for question or for whatever one. And then what I do is I get a question embedding, I get the embeddings for all the pages. I will find the embeddings of the page that is the closest to the question. I will get that page and give to the PaLM API to rephrase that for me as an answer. And this is how you talk to a document. So you can get your answers on factual data. So this is a way of grounding large language models to truth, to the reality. They will avoid hallucination when this construction happens. You can also train, of course, a large language model using these embeddings, right? This is more advanced. I'm not going to go into details here. So we can use embeddings for many things, information retrieval, to create recommendation systems, question answering, and that's all. Aside from that, we also released LLM magics. So a Colab magic is kind of a macro that you put on Colab that will do stuff for. So you can, for example, measure time of executing a cell on Colab. You can write a lot of text on a cell and create a write to a write file. Magic, it will just create a file with that content. There's a lot of magics. We create one for PaLM. So you can, for example, give one spreadsheet and get a spreadsheet as return. So here, if you get a spreadsheet with words and you say, hey, give me the opposite, it will give you another spreadsheet with the hot, cold, near, far, and this is a way of playing. It's a simpler way of using PaLM that's simpler than code, but it's a little bit more advanced than MakerSuite. So it's an intermediate there, right? And I want to talk also about the Google Cloud solution. So we have the PaLM API and MakerSuite, which is the open. But if you want to do some enterprise, you want to use that on your company, I would suggest you go for the Vertex AI Gen Studio. It's the same model, same idea. Everything I told you until now, it's exactly the same on Google Cloud. The difference is that you have all the cloud support around it, right? So all the tooling, all the SLOs, all the compliance stuff around cloud and generative AI. So this is, if you're going to do something, build something like a product, use the cloud version. They're the same idea. Everything's exactly the same as I was showing, but they have the cloud grade around it, and of course they're paid, right? So that's an important thing to have in mind, right? So if you prototype, you got an idea, got somewhere, you want to build a product, using a product, go to cloud, right? And I want also to talk a little bit about responsible AI. So these models specifically, they have, they can create stuff that's not real. First, some people call that hallucination, and then all of a sudden they give you an answer that looks like very real, but it's not. It's fake. It's a lie. So you have to pay attention to that. And they sometimes may say things that are not great because they learn from the internet, right? And so you can imagine they learn from places where people are not super polite, let's say like that. Of course, we try to train these models the best way possible, removing as much as possible from this content, bad content. But even with that, it's almost an impossible task to clean everything. So these models might have some stuff that is not optimal for all cultures. We, of course, have some filters. We can, for example, there's a toxicity content. If you send a prompt and the response is deemed to be toxic, the model will block it and say, no, there's no answer, right? And this is a way of helping you get better results, but you should always pay attention how you use the model, what kind of tools you're building, the values that are behind it, your values, the values of your company. So always pay attention to that. Responsible AI is very important, even more now. So always pay attention. We have some tools to help, but there's still things you have to pay attention on your own side. Given that, if you go to g.co/PaLM, you can get to the PaLM API developer site, create an account, play with it, and start your journey there. I hope it was helpful. I hope it was fun. You learned something. This is a brief overview of PaLM, MakerSuite, and large language models, just to get you motivated to go after and study more. And that's it. Thank you very much. I'm on many social networks. I'm Twitter here, but I'm on LinkedIn, the new threads. Also, might put this on the future presentation. If you have questions, come send the questions. I'm always glad to talk about these kind of things. And I post about this on a kind of very frequently. So yes, thank you very much. Do we have any questions?
Thank you, Gus. It was a good session.
Thank you.
We'll take a few question and answers now.
Yes.
Okay, what are the computation challenges to train LLMs?
So yeah, that's a very good question. So imagine you have to get all the internet and put in a format to train a model. That's a huge challenge. Just that. And that's challenge one. Just how do I get all this data in a format that can be trained, right? You cannot just give random stuff. Aside from that, these models, they don't fit into one machine, right? Training them requires many machines, and it's not only many processors on the same machine, it's many separated machines. How do you train a model that runs on many machines at the same time? So this is another part of the problem. The other part of the problem is, how do you evaluate this model? How do you say if they are good or bad? This is very hard, because how do you do that? That's another problem, and evaluating them is a problem. And then you get to the responsible AI part. How do you prevent these models to do damage that's easily preventable? Another challenge. So uh, training a model like this from scratch, I don't think it's something people would do easily. What people do is they can do fine tuning when necessary, and it's very specific use cases. For some specific models, you can fine tune them. And fine tune them, we have specific techniques to fine tune them, like the perform. How's the name? PEFT. PEFT is, I forgot what it means. Or there's another one called LoRa. So the idea is you can change specific parts of the model for a small part, for a small set of data that will make the model better for your use case. This is way easier because you just have small data set and you change a little bit here and there. But training these models is very hard. Lots of machines. You have to know how to distribute training, how to distribute the data, do the processing. So training this may take a month, for example. So it's not in a month, all full time, many machines. So it's very, very tricky. I don't know if I'll ever train one myself. A large language model. Language model is different, right? A small one we learn. If you go on the TensorFlow.org, there's many training a language model there, right? So, but a large one, it's another level. Next. Thanks, Manoj, for the question.
Okay, so for the next question is, I am working on LLMs and I want to learn more about fine-tuning LLMs. Any strategies to follow in fine-tuning LLMs? And
So
also, you were telling that PEFT, so we can use LoRa and QLoRa to fine-tune
exactly.
LLMs, open source LLMs.
Yeah. So for the open source ones, you can. There are some techniques that can do this. Let me find it here. I'll find later. PEFT. It's performance efficient tuning. Performance efficient tuning, or something like that. So it's a way of you tune specific layers. Sometimes you add a specific layer to the side that can help your model. There's a lot of very advanced techniques there that can fine tune your model. But the first question is, do you need to fine tune your model? Because we, as machine learning developers, you are used to anything I need to do, I need to fine tune to my data. And that's not true anymore for large language models. For some situations, you might need, if you need, for example, if your context is always full because you need to have a lot of instructions before anything. So maybe you can fine tune the model to already learn these instructions, right? This is a possibility. Or maybe you can fine tune a model to know all your documentation, your site's documentation. So this is might be a possibility. And the other thing is, some, for example, Google Cloud has a tune. You can fine tune the PaLM model there. Of course, it's not going to fine tune everything. It's going to fine tune an adapter, like I guess it's, I don't know which algorithm they use, but they do performance efficient tuning, a parameter efficient tuning, parameter efficient tuning. Sorry, now it's correct. They do that for you. Just give the data, they will do the tuning for you. So I would recommend using the cloud provider, because then everything is, you have a pipeline, everything is under control, you have qualities. You can do open source, but then you need to study way more. If you have the time, of course, it's a good thing to learn, but it's just more tricky. I would do that only if you really need. That's very important.
Okay, so next one question is, can we use PaLM API on custom data or LangChain?
Yeah. So for when you say custom data, I imagine if I understand, custom data is your data. I imagine yes, you can of course use PaLM on that. LangChain, uh, they had an integration for PaLM specifically on LangChain, like exactly like the other LangChain integrations. I don't know if it's there already. They committed. I don't know where is it today. I know that the Vertex AI Palm integration is there. It has the integration. It's exactly the same. You can do create a LLM from like a LangChain you would do using Vertex AI. You can definitely do that same thing you do with any other of the APIs compatible. The Palm API, last time I saw it was compatible, but I didn't see the documentation yesterday, so I don't know what happened. Maybe it's still compatible, but yes.
Okay, so next question is, does Palm only allow tuning, or do you have any other service on GCP that would allow to train on proprietary data? As I imagine, Palm is trained on a generic context, and tuning may not help in all cases.
Yes, that's a very good question. So for the Palm API, the one I was talking, for the regular developers, consumers, uh, if you're going to do your proprietary data, you have IP, go to the cloud solution. You should always do that. Cloud will guarantee there's no IP leak. The models, Google never trains your data on Google Cloud data. Of course, you train your model; it's your model. We Google don't use that. So this is a very important. If you have proprietary data, go to the train this on Google Cloud, and there you can fine tune the model to your data if needed. That's a very important thing. We have this. Oh, I need to fine tune. Do you really? Why? Because it has many costs involved into that, right? But you can train on proprietary data on GCP, and that's the recommended solution.
This question is already covered.
Yeah, we answered that already.
How many LLM models does Palm support?
So Palm supports the Palm V2. They, I know they had four models. I don't know if all of them are available. There was Bison, which is the second largest one. The largest one is called Unicorn. I don't know if that's available. There is another one called Gecko, which is the smallest one, and there's a second one. I'm second in the scale that I've forgotten the name. It's a name of an animal, maybe leopard. I don't know. And the idea they have these four models. They are all Google models, of course. They're all based on the same model, but with more parameters. They're just larger, and of course, if they're larger, they use more machine. They're more expensive. That's the idea.
Oh, okay. Usually LMs are very underdeterministic, and I find it hard to bring consistency in my output format with GPT-4 or open source. Is there something on Palm API that would bring consistent response format?
That's a very good question. So all LLMs will be undeterministic. That's very hard uh, to circumvent. That's going to happen. What you can There's some tricks, right? When I said about data prompt, where you give examples of inputs and examples of the output you want, that helps a lot, but it might not solve every problem, right? So what we try to think is, for some things, LLMs might not be the best solution. If you need the format to always be correct, and depending on what you're doing, maybe they're not the solution. Maybe they're part of the solution, but they're not the full solution. So learning when to use LLMs and when to combine LLMs with classical programming or regular machine learning models, it's an important thing. So I've seen people trying to solve some problems that classical programming would do better, and then you just use classical programming because it's completely deterministic and you can put tests, you have the consistency. So we have to always be careful how to use them. Of course, there's all this hype and you try to solve everything with them. They're not good for everything, definitely. So you have to learn where to put the bar here. I guess that my main tip, aside from this rant, is try to give examples of input, examples of output. That definitely helps. But it's not like 100% guarantee, unfortunately, for all models. There's, as you mentioned, open source, Palm, large language models. Oh, other thing is you can decrease the temperature to make sure the model will follow your guidelines as much as possible. So this is another thing.
So we'll take this last question. What is
Okay.
the major difference between generative AI and LLM?
So it's the generative AI is all machine learning that from text or from one thing creates another, and it can be from an audio creates another audio, from a text creates audio, video, image, other text, from an image create another. So this is generative AI. LLM is the large language model, is the models that given text create another text, right? Generative AI is larger than LLM. Let's say LLM is inside generative AI, right? It's one of the models we have there. LLMs are so important that they help in all generative AI, because every time you say create an image to do an image of a cat on a bicycle, right? This is a generative AI thing, but inside that, they are going to use a large language model at some point to extract embeddings, for example, from your request and convert that into an image or to an audio or to a video, right? So LLMs are inside generative AI. Just the last part is Google Cloud has Generative Studio, which is their tools to use generative AI. So you can generate text, audio, image, all of that is inside Google Cloud. The PaLM API that I showed and MakerSuite today is only for text to text. Last
Okay,
one, last
so
one.
he asked the same question again. Like we asked one more question. While a longer context window can handle lengthy inputs, including an entire document, without having to split and chunk, continued. The bigger question is, does a longer context window enhance accuracy of information retrieval?
That's there's I don't have. Yeah, yeah,
Asking
yeah.
this in the context on using LLMs on large set of
Yes.
documents.
So there's some studies on how much can we increase the context window. There's some papers people are studying. I'm not. I didn't follow the latest papers. They they claim that you can increase like endless, but I imagine there's the quality of the results might be weird. I don't know. I don't know. I have to look into the papers. But it's, and of course, the larger the context, the more memory you need, because the model has to look into thousands of characters to understand. So the more resources you need. Uh, I know that most models now are increasing their context window to some 30K and 40K tokens, right? But I still don't know what's the limit there. That's still research stuff. People are on the research are looking to exactly this question.
Uh, I guess we don't have any more question.
I'd like to thank you very much for the invite. Thank you, of course. I hope,
Thank you, guys. This was insightful.
thank you.
Even I'll say the same thing.
Of course, and I'd like to thank you. It was very good talking to you. I hope it was helpful and that people enjoyed, learned something. And again, if you need something, find me. Thank you. Find me on the social networks. I'm always there talking about large language models and many other machine learning topics. And that's it. Thank you very much.
Thank you, Gus, for accepting our invitation. And really, it was a great, insightful session. I hope people try out Palm API and MakerSuite.
Thanks, everyone. I really have to drop. See you later.